So this is our project number 2, Buxton challenge. And next. So who is Second Rex? So Second Rex is the discount department store who has 73 locations. They have experienced rapid growth in their key market. The objective of this project is to help Second Rex grow more efficiently by only opening up high revenue potential locations. In this paper, we build in this project, we built a Salesforce forecasting model that was based on the 2016 sales to predict the future performance of those locations using a dataset with variables that are specially generated and a variable that works with distance scores, customer values, and thus qualitative and quantitative. This paper is able to predict the best model to decide on a location.
Okay, so starting off with our first model that we did, the first question of kind of our objective followed the first question of interest, which is that to develop a model that will be useful in predicting the sales of a slacks on rack given the explanatory variables in the data set. So first we ran a PCA a PCA with regression, which is a PCR. But to decide which variables to use, we ran a random forest classification model, and we narrowed it down to about 5 variables that we deemed were important enough in dictating the sales 2016. And those are these variables that you kind of see right here. Is too tough to kind of go ahead and list out. After we used those variables, we kind of inputted them into the code for the PCR, and it separated these variables into principal components or PCs, and it found that the first two PCs, print1 and print2, were the most significant with low p-values of 0.0002 and for print1 and 0.0064 for print2. So now we had to see what these PCs were made up of to see which variables of the 5 are the most important, just to kind of narrow it down even more. Print1 we saw was consisted of these 2 variables that you see right here, and we saw that from the eigenvector table. You can kind of see like what each PC is made up of. And print2 was a little bit more clear. It was primarily this variable right here, ax foot 05ro. So you also got that from the eigenvector table. So we saw that those 3 variables that made up print1 and print2 were the most significant variables from the original 5 in predicting the sales 2016. In the output, we also saw that it gave an intercept estimate of the sales, which was approximately $6,243,480, and it also kind of gave a mean value of the sales, which was $6,149,627. So here is the output, some of the output for the PCR. In the top left table, you can kind of see the p-values. The 2 p-values that we saw were really important for print1 and print2. You can also see the intercept estimate right here. The eigenvector table on the top right, you can see that we saw that print1 was made up of primarily these 2, this variable right here and this variable right here, while print2 was made significantly of this variable right here with 0.764 eigenvector value. Then we also saw the standard just regression output in the GLM procedure, which gave values for just R squared and the root MSE and the sales 2016 mean, which I said before. So these are just also the regression graphs that were generated. So they just kind of dictate the regression and just the trends of each PC and principal component. So yeah, these were. This was kind of the This was just the PCR test that we ran. The next model that we did was our random forest regression, and that was a little bit easier considering we had already done a random forest classification to find which variables we thought were really important. So we just kind of added the regression code that was necessary. So as you can see, the variables were still the same, the important ones that we thought. But then with the regression, you also see that MSE and OOB MSE are given for each of these variables, and so as our just overall regression output stuff, just like fit statistics and average square errors of both the train set and the OOB. In the regression, we also implemented an HP4 score method, which then showed it actually produced a table which had a column under a variable called P_sales_2016, which actually predicted possible sale values, which you'll see in the next slide. So on the left side, you'll just see the variable importance table, which just showed that the first 5 were the most important, which were the ones that we extracted from that. The middle one right here is just some of the fit statistics that you'll see generated from the regression code. And on the right, even though it's really small, because there's a lot that kind of predicted, you can see the P_sales_2016 column, and it just has like a bunch of predicted variables or predicted values for sales 2016. So yeah, those are pretty much the 2 models. And this is just the code that we used. The top half of the code up until here is all of the random forest regression, and this bottom half right here is all just print comp and PCR kind of code. So yeah.
So our second question of interest was our part 3. The question of interest was basically to provide inference and guidance as to which explanatory variables in the data set are useful in predicting where to place the slacks on racks. We decided that the variables from Model 2 and predicting sales 2016 were the strong predictors of that model, and that they would be strong predictors of where to place a slacks on racks. The variables are listed here. And the age variable used in that model had an AIC of 92.625, and then it also had a p-value of 0.0372, and so this showed that they were strong predictors of where to place a slacks on rack store.
So to sum up, the data set provided a set of influential variables that provided inference in which location the second racks should expand to. When looking at the model that we developed, the most useful one is the sales 2016 model. The explanatory variables from this model will be strong predictors of where to put a store, as they were good predictors for sales. Second racks should look at this data and use those variables to decide where to put their next store.
Yeah, so that's it. That's cool, exactly.